All right. Hello, everyone. Thank you for joining this workshop. Um, and I would like to thank you for attending this nice conference and also attending this workshop. So today I'm here with you, Tuhin. So let me share my screen and then start. Um, if any of you could just text me that whether you can see my screen, that would be great. I hope all of you can see my screen. Can somebody confirm? Yeah, that's great. Thank you. Thank you so much. Thank you. So again, thank you so much for joining this workshop. Today, I'm going to instruct you through this introduction to our workshop. And as you all know, that this is a part of the UConn Sports Analytics Symposium 2021. Um, and thank you for being a part of it. So let me go through step by step. So if you go through the Symposium website, and if you click on the workshops, you will see that there are a bunch of 6 workshops we have designed for you. The first one is the one that you are attending right now. So if you click, I hope that you already read out all the details. And to access the materials, so if you click on the GitHub link, so this link will take you here. So where I created a dedicated repository just only for this conference. And then on the right side, if you see that there's a link where I created a hyperlink to access those slides. And also there are a few other files here, like the R codes UCSAS 2021. So if you click on that file, so you will access all the source codes that you might need if you want to go with me. So I would suggest that click this link to access directly to this slides. So I can make it full screen, but I might go back and forth in the RStudio. So let's keep it there if it's okay with you. So for today, we're going to start from the very basic things. So as I already told you that this is a part of UConn Sports Analytics Symposium, and all the details of the workshop that I already showed you demonstrated through those links are also available in the slides as well. And as I also sent you an email yesterday regarding some prerequisites that if you can download R and RStudio, that would be great. And if you want to go through the slides with me, this is also fine. You can try later on, and I will show you some hands-on examples in this workshop. So a little bit about myself. My name is Tuhin Sheikh. I'm a 5th-year PhD student at UConn in statistics. So broadly, I'm working on quite a few research problems, starting from computing risk, longitudinal data analysis, deep learning, and interim data, microbiome data a little bit. And in the future, I really want to be a professor in stat or biostat, so that I can continue doing research and teaching at the same time. So I also do have my website link. So if you are interested, you can go through and learn a little bit more about myself. So for the workshop, actually, I don't expect that you have a lot of experience with R. In fact, little to no experience is completely okay. And the only thing that I would request, so if you have that enthusiastic attitude that I really want to learn something new today, that would be enough for today's workshop. And also, this is just 50 minutes workshop. So I planned a lot of things, honestly, but I'm not sure whether I could be able to finish all of the materials. But still, the materials will definitely help you to go through later on, and also you can go through the videos. So it's already been recorded, so you can access the video maybe at the end of the conference. So roughly, the aim of this workshop is to introduce you with the syntax structure, data manipulation, basic functions, some libraries, resources, and RStudio, which I will talk in a minute. And I will also try to give you a real data application, so you actually know what you are learning and how you can apply those things in real life data example. So this is the broad outline of today's workshop. And I'm going to talk about our basics, file system, data structure, read and write data, data management, and brief overview of one package. And of course, the time is really limited for this workshop. But if you have any question, you can type in the chat box, and I will try to answer. And if not, then we can contact later on. You can send me an email. I will show you all my contact details so that you can contact with me in the future. So first of all, as I said, I don't expect that you have a lot of experience with R. In fact, no experience with R. So a little bit about R. What is an R? So R is a free software. It's really popular nowadays for statistical computing and graphical analysis, display, visualization, and it ranges from different words like import, export, data manipulation, visualization, doing analysis and report. And I also didn't list all of the things. You can also do web development applications through R as well. And to know a little bit history behind R, if you just go to their official website, R project. So this is a hyperlink. So all the links in the slide, if you see those are blue, that means the hyperlinks are already given. If you just click, it will take you to those original website. And R is named after this two scientists. So their name starts with R. So that's why the software has been named after R. So again, this is the first question that usually people ask me, or if you are a new learner, you might ask yourself. So if there are a lot of softwares or programming languages in the market, so why should you learn R? So there are a couple of reasons. These reasons are just written by me. So there could be many more reasons which other researchers or programmers might think about themselves. So you might see my cat in my behind. I'm sorry about that. She wants my attention all the time. So R is a free and open source, and it has a very user-friendly IDE, which I will talk in 2 minutes, I suppose. And it can be used with other languages. So this is a very good point about R. So if you like to do work in other languages like Python, C++, or even Fortran, you can integrate multiple languages together. It has a very nice visualization library. It is compatible with most of the famous operating systems like Windows, Apple, Linux, and it has a very large user community, which is really very important. So once you start digging into any programming language, you will see that you'll stuck at some point. You might need some experts' advice, and you may not find some people immediately. But if you ask the internet, there is a huge user-friendly community which can help you. And so what is IDE? IDE is an integrated development environment for R programming, which is usually called RStudio. And if you have heard about any programming language, so it requires some technical pathway so that your program can go through, compile, and give you your result. So IDE often help us to submit our work, to produce our reports, to visualize our graphs very simply, rather than just going through the original, only the R software. So RStudio is much more easier to deal with than R. So since I believe there is no question yet. Okay, so let's move on. So I assume that you are pretty new to R and RStudio. So once you click RStudio, you will find that RStudio has four quadrants, like four blocks. So the first block is called the code editor. So you will write your code here. And once you write your code, you need to run your code at this console. We call it console. And on the right, two boxes or blocks, you can see there are a couple of things like our environment, history, and connection. They have different functions. Like environment will tell you like where you are. History will tell you what are the programs you have already run. So if you want to go back to previous code, you can go through the history. And plots, like these lower blocks, it will keep you or help you to track your file system, your plots. If you have just generated some plots, you are not finding it anywhere. But if you click plots, you'll see what are the plots you created. The packages, what you have loaded, will help you to go through some manuals if needed. So I can let me show you. Let me show you the actual RStudio. So this is the RStudio. So the file that I provided you through the GitHub repository, if you click and open, you will see that I gave you all the source codes that will be needed for us to go through all the examples. So this is the RStudio. So now you can see it in real. So let's go back. So now let's dig into R now. So far we just talked about like for the last 10 minutes. So I think I'm gonna stick with the time pretty well. Okay. So we just learned what is R, what is RStudio, and why, what are their uses. So now we are going to see the actual application through RStudio. So the first thing that I want to show you, that R can be used as a calculator. So whatever we do in a calculator, you can do the same thing in R. So like 5 plus 7. So let's do it. Let's do it in R. So if you go down to the console and write 5 plus 7, and make it a little bit bigger, and then hit enter. So I hope you can see it shows 12. So it's that easy. And this editor is actually really useful in a sense, because once you run your code in the console, it will be populated with all your code and outputs. But the editor will keep you track. Like if you want to edit something, if you want to change something, if you want to use it repeatedly. So editor really helps. So from the editor, if you write something here and you want to run it, so you can run it multiple ways. One of the ways is to keep the cursor over there, and then you can see there is a run button here. So if you click run, so it will run. Or there are other options which I don't want to stress a lot because you can customize it. But usually, like if you type press Control plus Enter, this will also help you to run the code. And on the right side, as you can see, there's something I wrote using the pound sign. So this pound actually used for comments. So if you want to help yourself or want to keep something so that others can read your code later on, so you can type something which R will not compile. So R will consider that these are only for comments. These are not actual R functions. So again, so exponential, if you want to do exponential of 5, just type exp. Because this is a high-level language, so those functions are very similar to the way we write in our textbook or in the research papers or in the manuals. So like if you write log2, so you can do it. Let's go back to the slide then. The next thing is one of the important parts is asking for help, because you will be at some point where you really don't know how to deal with something. and how to use some functions. So, okay, you know what is what function might be used to mean. Like I'm telling you that mean is used to calculate the mean of some values or some data, but how to use it. So if you don't know, write question mark first and then type MEAN, so mean. And if you hit enter, you'll see, as I showed you, that on the right, this block, there's a help button. It will start, it will provide you the documentation page of the mean. So it has all the examples of the arguments, how to use it. And also it provides some examples as well, how to use it. And there is another nice thing about R, that once you know that mean, if you close the parenthesis, first parenthesis, start and end, and then if you click tab button in your keyboard, it will allow you to go through all the arguments it has inside that function. So we'll talk about that in a minute. So let's go back to the slide. The next thing we'll talk about is called the assigning operators. So something you want to preserve in R, how you want to do that, how you can store some, either it can be character, it can be values, it can be numbers, how you can do that. So there are several ways, but one of the easiest ways that we usually do is writing some value, some operator like X or Y, then less than and hyphen sign is used. So if you want to assign something to X, so it can be like hello world, and then if you hit enter, and then if you want to check, press X and then hit enter. So it will show you that inside X you have one component which is hello world, which is a character. So you can do different things, like X can be 5. So if you just plug in X and then write X, so you can see X equal to 5. And there are some other ways which I don't want to spend time now. So it's in the slide. You can see these. These are for you to go with later on. Then so far I just only showed you one number or one character. So you can do actually more than one. It can be in mathematics we call it a vector. So a vector means a list of numbers or list of elements within some operator that you're assigning. So for example, if instead of 5 you want to combine more than 5 or more than one component, so as you understand intuitively, it's called combine. So C is another function in R, so which stands for combining. So C and separate the other numbers by comma, so it will create a vector of elements separated by comma. And as in the slide, you can see that this brackets, square brackets. These square brackets are used to go to certain element or the location or indexing or subsetting of a vector. Say for example, if you type x1, so it will give you the first element of your vector. So if you type x3, it will give you the third element of the vector. If you type 1 through t, this colon is often used to, like, if it is uniform 1 through 2, then the first two. If you want to see the 1 and third element, so again you can create a combined function and a vector of location like 1 and 3, and then hit 1, 3, so it will show you 2 and 8. So there are a couple of ways. I kept some examples here so that you can try it out later on. Oh, there is no question here. Okay. All right. So, and of course, as I told you that this is a 50 minutes workshop, I might not have time to show you all of the things, but I listed those things in the slide so that you can practice and try later on. For example, I can show you one of the examples here. Like we have length, we have names, we have replication. So the replication function is really interesting. So sometimes it is needed that you replicate the same thing more than once, more than twice, or you might want to replicate or repeat certain element multiple times than other. So this ref function is really interesting. So the first example, as you can see, inside the ref function, there is a vector like 1, 2, 3. And then one argument is called times. So times means how many times you want to replicate this whole vector. So if you type 2, so it will create 1, 2, 3, again 1, 2, 3. The second example is also interesting. It says the argument is not times anymore, it is each. So each means, so it will go to each element of the vector and repeat it twice. So if you see on the right side, as I already told you, that count can be used as a comment, which will not create any problem when you run any code. So you can see 1, 1, 2, 2, 3, 3. So there are a couple of other examples you can try. Like I can show you one, the length. Okay. So now we already have created a vector called x, and in x we have 2, 5, 8. So it is very simple because we have only 3 elements. Sometimes it might have many elements, so you don't want to count. So there is a function called length. So if you type question mark and the length, you will see in the description and in the argument that in the length, if you type length, and then in the parenthesis, if you type the vector that you created, if you then hit enter, it will tell you it's 3, or the dimension or the length of the vector is 3. So I would suggest that there are many other functions, interesting functions here. So you can go through and use a question mark and try it on your own. So there are other couple of functions which are used for ordering, subsetting. Again, you can go through this function. So one of the functions I can show you. So let's write intentionally create a different vector. So where we have like 2, 2, 5, 8. Now if you use the unique function and then select x in parentheses, hit enter, you'll see 2, 5, 8. So it will only give you the unique numbers. So this is sometimes really helpful or useful because there could be some places you want to have your, like for example, the attendees are attending in our conference. So if I have the data from different section, I might have repeated names, right? I want to have the unique names. So then I can use this unique function. So this is a tiny example or quiz, I would say. But I already did this whole example for you. I showed you the length. I showed you the unique function. I can also show you the sort function. So there is a function called sort. So sort helps to order. So if the numbers are not in order, then you can use sort and write the vector. It will sort those elements for you. There are other elements like is decreasing or increasing. So if you want descending order, so you can select the decreasing equal to true, and then it will give you 8, 5, 2, 2. So in this way, you can play with this. So I also provide you all the solutions in the slide. So this is something just fun fact. We can play and we can learn together. Let's see. Okay. So all right. So there is no question. Okay, so a little bit about data structure now. So because when you learn or when you decided to learn R programming, you definitely may want to deal with data set. And of course, the data sets could be of different types. Like it can be numeric, it can be characteristics, variable, string or text. It can be logical, like yes, no, true, false. It can be unidimensional, just the way I showed you, the vectors. It can be two-dimensional, like you might have some rows, you might have some columns. It might be more than two-dimensional. It can be an array. So these are the things, some basic stuffs I know, but it's really good to learn or good to know. So this is a tiny bit of things. I already talked about vector. So vector is a list of elements of the same type. And I also showed you like we can use the square brackets to go through the subsetting and also to the location. There's another function in R which is called list. So the nice thing about list is that for the vector, like this combine function, this needs to be of the same type. Like you cannot combine numbers with characters. But list is interesting in a sense that it doesn't need to be of the same length. It doesn't need to be of the same type. So if you want to keep different things together in a list, sometimes it is useful. You will know later on if you start using different packages, you will see some of the outputs are characters, some of the outputs are numbers. Then list is really interesting. Like I can show you one example from here. Like this function list. So if I type list, then listing different things together. So list a vector of length 2, a vector of length 3. So different things. So now if you type X and hit enter, you will see it is coming differently. It is showing me the outputs a little bit different way. So the indexing is quite different. So now instead of one square bracket, we have to use two square bracket to go to the first list. And if I want to go to the second list, two. So it is useful. You may know whenever you start using different packages and other stuff. So I also kept something called array and matrix. Sometimes you might want to work with matrix in R. And if you are not familiar with matrix, the matrix is something when you have something in the rows, something in the columns. So this matrix function really helps you to create the matrix. And this array is a more generalization of the matrix where you can go beyond 2 dimension. Like you might have rows, columns within some index, rows, columns within another index. So it's all about indexing. Like I can create indexing from like the country, from the states, and then from the university, from program. I can create different kind of indexes, and which might be useful in my data analysis or some other works if I want to do. And the indexing for the matrix or the dimensions are really simple in terms of R, because you will just keep using. So let me show you one of the examples so you have some idea what I'm talking about. So I created a matrix. So a very simple matrix using the matrix function, which has 1 through 6, 1, 2, 3, 4, 5, 6. And n row is the number of row defining how my matrix should be. Then if you click X, it will show you n row, that is 2 row. And since I have 6 elements, so it automatically creates 3 columns. So that I have in total 6 elements. So now if you want to get into one of the specific element of this matrix, so you can type like 1, 3. So it will go to first row, third column. So this is just, I wanted to show you the indexing of matrix, or also in the array the same way. So there is a tiny quiz for you. I would suggest that that if you are going through the slide and also going through the video, you can try this quizzes later on. And I also provided you all the solutions from the quiz. So we have around 20 minutes. So I think I'm pretty much good with the time so far. So I want to talk about a little bit of functions and looping. So function is something that you already saw, that I used mean function, I used length function, I used unique functions. So when you start working in the real world, you'll start thinking that, okay, so what is the function that I want? It does not exist in R. So I have to create my own function. So the structure of creating function in R is not that difficult. This is very straightforward. So you write your function name, then there is a function called function. So you need to write function and then specify your arguments and some operation with that argument. That's it. So I created a very tiny example of finding absolute value of x. X is something like is a variable you can change. So if x is greater than 0, there is another function that I'm using, which is called return, is the output, like what you want to see at the end. And if not, then it will just multiply with -1. That is what we do, right? So if we have something -5, we want to see 5. So what I wrote this function for you. So if you want to use some function, you wrote. So first thing you need to do within this curly braces, you need to write all the argument, all the operation using the argument, and then you have to run this function first. So if you go and hit run, so now in your compiler, in your console, you'll find this function. So like if I type find underscore ABS, so it will allow me to use this function, which I created myself. And then if I type -5, so it will give me 5. If I give 5, it will give me 5. So it's working. So again, this is a very tiny example, so that you can try use the same logic, same strategy, and try on other problems. So this is the quiz I wrote for you. So again, I'm not going to wait. So when you're going to finish, because of the time constraint, we have just only 50 minutes. So I want to provide you the answers also, but I would request you that when this workshop is done or when the conference is done, you can take advantage of the slide and the video, and then do these problems on your own. So the next piece is looping and conditioning. So looping and conditioning is really important as the word goes. Looping means you want to do something repeatedly. You want to move something repeatedly. Conditioning is something you want to give condition. You want to filter out something. For instance, like if I'm interested, how many undergraduate attendees we have in our conference, how many graduate attendees, how many professors, and how many professionals from the industry, then I'm just giving some filters. I'm giving some condition. So for R, there are a couple of ways to do the looping and conditioning. So looping, you can do it using the for. We call it for loop or while loop. So for loop is something that excuse me, it starts with something and end at something. While is you will initialize the looping, and it will end when you specify some condition. So let me explain a little bit. Like the syntax structure in R is that it starts with for and the parenthesis, and I is the index. So it needs not to be I all the time. It can be anything. You can write it J, K, anything. And this in means what are the boundaries of this indexing. So the first thing, it starts with 1 and go to 5 with counting 1, 2, 3, 4, 5. And then for showing you, I wrote a different variable like index, and then assign these values into the index so that you can actually see that how this looping is working. So I can show you one example that I created for you. Like if you hit run, so you will see that each time it is getting into the loop from starting from 1 to 5. So I just printed all those outputs for you so that you can actually see how it is working. And this print is another function, since I already told you that if you don't know, just write question mark print and hit enter. So it will show you how to use this print function. While function is very similar. So it need to initialize first. For example, I is equal to 1. So I run I is equal to 1. Then it will do some operation until some condition is satisfied. So I said, okay, so stop while I is equal to 5. So if I run it, you'll see start with 1 and goes through this looping until I equal to 5. So each time it is adding 1 with the index. So sometimes these are really important or inseparable part of a program. So there's some other ways for conditioning, like the language we know, equal, less than, greater than. I might not know. So like less than or equal, you have to write less than equal sign to do the job. And okay, so let's just skip here. And then we have if condition as it sounds. So if some condition works, do some job, else do another job. So I just have a tiny example for you, like for loop, and within the same loop, I just added another condition. If I is not equal to, so this exclamatory sign and then equal means not equal to 2, only then print it. So so let me show you one example that I created. So if I run it, so you can see it is showing me 1, 3, 4, 5 and is skipping the 2. So I again have one quiz for you. When you are reviewing the slides, try on your own. These are very self-explanatory. I wrote all the comments on the right side of each output. So if you do it, then it would be great. So then this is the last piece. So far, okay, so I have around 10 to 11 minutes. As I promised in the beginning that I'm going to show you one real data application also. Also, of course, this is very tough in a 50 minutes, but I designed it so that I can finish it. So for this example, I'm going to use one package called layman. And within that layman, we are going to use one data set. So here you are going to learn something that R has a lot of packages and how to install a package. So let me show you how to do that. To install a package in the console, you need to write install. And also you can see that IDE is helping me to select those functions. If you can find that installed packages, at this point, instead of writing, you can click the tab or hit the tab button. And then in the inverted comma, if you write layman and hit enter, if you need to have the internet connection for that. So it might take some time to install the package. And as you can see, it's going through some steps to download the package. And as the function says that install, so it is installing in your computer. It is not loaded yet into this console. So the second piece we need to do is to library this layman package, and then it is ready for use in your console. Okay, so now the next piece, in many of the packages, there's some data sets available. And if you want to see, okay, what are the data sets we have in a package, then you can type data and then package equals to layman. Then it will show you what are the data sets you have in this package. So there are a couple of data sets. The author of the package already loaded for you so that you can do some tiny example. And here from the list of data set, if you decided that I want to use some data like bedding, then you can type data, which data, in the inverted comma, bedding, and then from which package, layman, and then hit enter. So it will load the data set into your console for usage. Okay, so what I did few steps, like I wrote a data set, and then the second step I did, okay, so I want to use the bedding data from this layman package. So it is already loaded. Okay, so now if you want to see okay, so these are something that you can go through later on, how you can read data and load data or save data from different sources. So read.table, write.table, read.csv. So these are some useful functions you can go through later on. So as I showed, that data bedding package can be used. And then this is an interesting function called str, the structure of data. So if you type structure bedding, so it will help you. Okay, so what are the variables I have in this data set? So like if you type str and then bedding, so it will show you, okay, so what are the variables you have? What are the types of variables you have? Then head is interesting. Like head means the head, like the upper half. So head means only few rows. So since it has a lot of rows in the data set, actually you can also see how to see the dimension. So if you type dimension and then bedding, it will show you, you can see more than 108,000 data set we have in this data. It's really big. But if you type head, so head will help you. Okay, so give me only 6 or 7 rows, 6 rows. I just want to see only a chunk of the data, not the whole data. Then the indexing is really interesting. So if you want to subset the data set, like I want to see only few columns, like the first 4 columns and all the rows, then you can use comma blank in the first place and the index of the column, which column you want to see. So like if you type bedding 1 through 4, so it will show you the 4 columns, the first 4 columns. And if you want to see what are the column names, so if you type names bedding, so it will give you all the names of the variables. Now, if you want to get into a particular variable, particular column name, what you can do, type bedding, and then use the $sign. So this $sign is helped to bridge between the data and the particular column name. So if you type player ID, so it will show you all the player IDs in this data set. Then you can play with this indexing a lot, honestly. So like if you want to see only the first 2 rows, 4 columns, you can do that. If you want to type a particular column like player ID and year ID you want to see, and the first 4 or 10 rows, you can also do that. If you want to create a new variable, so again, the way you access an old variable, the same way you can create a new variable, like bedding CS_S0. If this is the variable I want to create, which is simply a summation of the existing two variables. Then with this with function helps R to know that I want to work with this bedding, so that when you write CS and SO, it actually knows that which these variables are coming from this bedding data set. So if I show you from here, so this will, then if you type names bedding, now you can see CS underscore S0 is another new variable. Actually, you can do this same thing in a little bit different way. Like instead of using with function, if you use CS and then plus bedding. So this is the same thing as using the with function. So with function actually helps us to, okay, so we only have a few minutes left. Again, these are some tiny little quizzes I created for you just to deal with some tiny example. Like if you want to go to a specific location of the year ID, as I showed, equal means double equal in R. Greater equal means greater than equal in R. So you have to use that syntax structure. This and the same meaning as and. So if you want to have multiple condition, you want to subset the data, you can actually do that. And there's an apply function, which can be used for different purposes. If you want to have some summaries of all the columns of some function, like if you want to see the mean of different columns, then apply helps you to do that. Apply, then data set, 2 means column, 1 means row, and then the function name. So you can just play with the apply function a little bit if you want. And then the last piece I just want to introduce, that would be enough for our workshop, and the other things are available in the slide. So this is called the dplyr package. So the dplyr package is really interesting. It gives you a lot of access to advanced level coding structure, like this pipeline. So if you are familiar with pipeline, that's good. If not, then you can learn. So this pipe helps you to reduce a lot of syntax, and then sending this salary data, and then use some function which are built in the dplyr package. So the way we did, we selected the combine code that select the player ID or year ID with the inverted comma. So select actually helps us to reduce some code, clean code, and then do the same job, but in a more smart fashion. We have another function called left join. So if you have multiple data set with the same kind of ID structure, then with some common variables, you can merge data set using the left join, right join, or join. So you can explore a little bit from there. There is another function called arrange. Arrange helps you to arrange the data set by different set of variables. Like, for example, for the attendees, if I want to arrange first from the country, second from the state, third from the university, fourth from their profession, so I can do that for using the arrange function. And we're almost done, so it's almost 50. So I want to wrap up. So the resources or the references I used for this workshop, honestly, most of the things from my experience, I didn't use it from a lot of resources, but the resources from where I learned. So these are the resources. Like the first one is these are accessible to all of you from the web. So the R programming for data science, intro R, advanced R. So all these sources are really nice. Okay. So with that, I would like to thank you, all of you, for joining this workshop, and I hope that you enjoyed or you learned, or at least I made the door open for you for the new resources. And please feel free to contact me if you have any other questions or any other queries regarding this workshop, or it can be beyond only this workshop material. If you want to talk with me about other aspects of R, if you want to start learning, please feel free to contact me. So with that, I would like to stop here, and I would like to have some comment. If you have anything, I'll be ready to answer. And yeah, so if you have any questions, so this is a very good time to ask. You can type your question in the chat box. Unfortunately, I can't unmute all of you. Yeah, thank you so much. Thank you, Brian. So I will wait for a few minutes, and then, so let's stop the recording since our main part of the lecture is done, and I will wait for your comments. Stop recording. Stop.